Hello everybody. In this video we're going to go through 5 different examples of reflections, and each one's just a little bit different, but it will show you the 5 different types of questions that you'll come across in your IXL assignment. You'll notice in each screen I have these coordinate rules for reflection, and I don't want you to memorize these, but I do think that they're an important resource for you to have as you're working, especially since we don't have physical paper to work on and we're just doing this on our screens. So our first example asks us to graph the image of this square after a reflection across the x-axis. And if we look at our coordinate rules, the x values are going to stay the same and the y values stay the same, except they change signs and become the opposite. If we look at our picture, we have our x-axis right here, and if we're reflecting over that, it makes sense that our x-coordinates aren't going to change because we're going across this way and we're not going to the left or right in any way. And then our y values just become the opposite. So k has a y-coordinate at +4, so we're just going to go straight down to -4. And n has a point y value at +8, so we're going to go down to -8. Same thing with point m, it's at +8, so we'll be at -8. And same thing, L is at +4, so we'll go to -4. Our second example, now we're reflecting across the y-axis. So now our line of reflection is right here. And when we reflect this direction, now the y values are going to stay the same, but our x values are going to be the ones that become the opposite and change signs. So our y value at point R, we're at 0, so that's going to stay the same. Our x value is at -2, so we're going to go over here to +2. This point is also at -2, so we're going to go to x value of +2. And then finally s is at -6, -5, so we're going to go over to +6, -5. And we can see when we connect these dots that our shapes look the exact same, just a reflection, and we can double check that each time. They should look the exact same because we know every time we're reflecting, it's one of our transformations that keeps the shape congruent. It doesn't change the size, so it should still look the same, just reflected. Now we're going to reflect across a line at x equals 3. So if we look, x equals 3 is right here. So we're going to reflect across this vertical line going through x equals 3. Okay, and when we do this, we could have done this on the past ones also, but you'll notice we don't have a rule to even think about on this one. So when we reflect across a line that is somewhere other than one of our axes, we are going to just look at the distance each point is away from the line. So point G is 2 away, and we're going to go 2 away. H is 2 away, so we're going to go 2 away the other direction. E is 1, 2, 3 away, so we'll go 1, 2, 3 the opposite direction. And then finally F is 1, 2, 3 away, so we'll go 1, 2, 3 away. And then create our shape. When we reflected it, it was still a horizontal reflection, so the y values don't change, but the x values do. and they maintain the same distance away from our line of reflection. All right, so now we're going to reflecting across a line that is going diagonally. So when we see y equals x, what that means is all of the points when our y value is equal to our x value. So 1, 1, 2, 2, 3, 3, 4, 4, and at this point you should be able to see the pattern. This is going to form a diagonal line going through each of those points. So if we're flipping across this rule is the one that happens. So x and y, if we look and compare these, they actually just switch places. So whatever number is in our x coordinate, that's going to become our y coordinate, and whatever number is in our y coordinate, that's going to become our x coordinate. Okay, so this is one where I'm going to show these points in a table, and we have points C, D, E, and F. Okay, so point C is at 0, -8, so I'll write that in here. Point D is at 0, -3. Point E is at 4, 0. And point F is at 4, -5. So when we reflect this, if we follow this rule, we know our y and x values are just going to switch places. So one way you could do this, and when we graph our image, these points just become the same with this little apostrophe afterwards, which means prime. So C prime, if we switch those coordinates, it will be at -8, 0. D prime will be at -3, 0. E prime will be at 0, 4. And F prime will be at -5, 4. And then you could just go ahead and graph those points. You could just figure out what the new coordinates will be as you're looking at this. So if this is 0, -8, we're going to be at -8, 0. And this is at 0, -3, so we'll be at -3, 0. This point's at 4, 0, so we'll go to 0, 4. And then this point is at 4, -5, so we'll go to -5, +4. And I know this is hard to imagine on the screen, but if we tilt our heads and imagine this being a piece of paper and we were folding it in half across this line, then these would match up, so it looks like we got it right. If we're talking about the distance away from the line here, like we did on our last problem, this is 3 away horizontally. This is 3 away vertically. This point is 1, 2, 3, 4 away horizontally, and this point is 4 away vertically. So that's kind of how the distance away from the line of reflection shows up in this problem. If that helps you, you can think of it that way as well to get your new points. And our last one, now we're talking about reflecting across the line y equals -x. So this time, it's the same, our diagonal line, except in the opposite direction, because this is +1, so our y value will be -1. +2, -2. +3, -3, and then this diagonal line is going to go through each of those points. Okay, so there's our line of reflection that we're imagining here. And we could do the same thing we just talked about, go the distance. So this is 1, 2, 3, 4 away. So we would go 1, 2, 3, 4 away horizontally. Point G is a little bit further. It is 11 away. So we would go 11 away horizontally. I'm also going to show you guys, though, the tables like we did on our last one to help you see this rule. So when we're reflecting across y equals negative x, our y and x values switch spots again, but then they also both change signs. So some of our values are positive, they'll become negative. Some of our values are negative, they will become positive. And we're doing points D, E, G, and F this time. Okay, so we'll start out just writing the coordinates that are there. We have -2, 6. Point E is at 3, 6. Point G is at 1, 10. And then point F is at 6, 10. Before we even graph anything, we could come up with every point after the reflection. So D prime, E prime, G prime, and F prime. And X and Y coordinates are going to switch spots. So instead of -2, 6, this will become 6 and 2. And then remember, our signs switch on both of these. So instead of +6, this becomes -6. Instead of -2, this becomes +2. And I already graphed points D and E, and D is at -6, 2. Point E, we're going to switch the 6 and the 3, and they're both positive, so they will both become negative. So this becomes -6, -3. And we haven't graphed that one yet, so I'll do that. -6, -3. And that's our E prime. This was our D prime. Okay, G prime. 1, 10, if we switch those and then they're both positive, they will both become negative. So we have -10, -1, and then our last one, both positive, so they will both be negative, and then they switch spots, so -10, -6. Okay, G prime. We graphed that already right here. And then F prime, -10, -6. So there's our final point. So those are the 5 different types of examples. As you're working, it's up to you how you do these. If it's helpful for you to use these rules and write out the coordinates and then apply whichever rule to get the new coordinates and then graph those, you can do that. And then again, if we just want to focus on visually, what is the distance from our line of reflection, we could look at it like this. This is 1, 2, 3, 4 away vertically. So this one will be 1, 2, 3, 4 away horizontally. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9 away vertically. So this will be 9 away horizontally. Okay, so it's totally up to you how you solve these. Both of those, as you can see, will get you the correct shape after the reflection. That's it for the day. Good luck on your IXL.